We are now on Module 3 on our subject Mathematics for Grade 10 level. And the Module 3 is all about geometric sequences. For our lesson 1 of this module, we are going to focus first all about the common ratio of the geometric sequence. And at the end of this lesson, you are going to be able to illustrate geometric sequence using the common ratio.
Going to find the ratio of the second number to the first number. So in your place there, I want you to have your pen and paper. You need to find the ratio of the four numbers given or indicated in your screen. Okay, I will just give you 2 minutes to answer your activity. Okay, so your time starts now. Remember, find the ratio of the second number to the first number, not the other way around. Okay, time's is up. Let's have your answers. Who can give me the answer or the ratio of number 1? What do you think is the answer?
4.
Correct. That's 4. How did you do it? That should be 8 over 2, or 8 is to 2. So since 8 is the numerator and 2 is the denominator, so, sige. So since 8 is bigger than the denominator, so it means we can divide it properly. So 8 divided by 2. That is why your ratio is 4. Now how about number 2? What's your answer?
-3.
That's -3. Very good. Why -3? Why -3? Why
Ang
not
9, sir,
positive?
i-divide sa -3.
The 9, we divide it by -3. Remember the rule in the signs in division? If they are unlike signs, the answer will always be negative. So 9 is positive, 3 is negative, they are unlike, that's why your answer is negative. How about number 3? What's your answer?
1/2.
1/2.
1/2. Okay, very good. How about number 4?
-1/7.
Negative
-1/7.
1 over 7 or 1/7. Okay? Since 7 is your numerator, which is smaller than 49, that is why 1 is at the top and the 7 is at the bottom or the denominator. Very good. So you know what is a ratio, because this one will be important when we are going to deal with the common ratio in geometric sequence. Okay? Now, I want you to get a piece of bond paper if you have there in your place. Do you have a bond paper? Let's do the activity that is given in your module.
Sir,
Okay? Yes. Do you have your bond papers now?
Yes, sir.
Good. Now, I want you to fold it into half. When we fold it, just unfold it afterwards. I will stop. Now, here's the bond paper. Now, my bond paper is long, so it shapes as a rectangle, okay? Now, if we have to fold it, 1/2 of it, we fold it first, 1. So, yeah. Then we unfold it after. How many rectangles can you have right now after you unfold?
2.
2. How many times did we fold it?
Once.
1.
Okay? Now this time we'll do it the folding twice now. So we've done it once already. We just fold it one more. So that's 2 times now. We fold our paper. Okay? Now if we are going to unfold the paper again, what do you think will be the number of squares that you created?
4.
4.
Four.
Or you
4.
there should be 4 already. Okay? So you can see
Four,
4
sir.
shapes now. Very good. Now this time, we will do it 3 times. You will fold it the 3rd time. What do you think are the number of squares or rectangles that we formed in our bond paper?
8.
8.
Sir.
8 or
8.
6.
8 or 6?
8.
Sir.
8.
8.
8, sir.
6.
It should be 8 already. Now, question. Is there a pattern in the square or the rectangles that we formed already? Is there a pattern na?
Yes, sir.
Yes,
We
sir.
formed a pattern? Yes. Very good. And what is that pattern? What are the sequences of the numbers of squares? First, we have
2,
2, followed by,
4,
4.
4, 8,
and then it followed by
8.
8.
now, 8. what if we are going to fold it the 4th time? What do you think is the next
16.
sequence?
16, sir.
16.
16.
Should be
16.
16. Okay? Okay? For the 5th time, what will be our number of rectangles that being formed?
32.
It will be 32.
32, sir.
Now, the numbers 2, 4, 8, 16, and 32 is what you call a geometric sequence. Okay? Now, what is a geometric sequence then?
Also called geometric progression. Each generated by multiplying the preceding terms by a constant non-zero. This constant non-zero number that we multiply to the terms is called the common ratio. It is denoted by the variable r.
Okay, so geometric sequence is also called the geometric progression, wherein each term after the first is generated by multiplying the preceding terms. So this constant non-zero number that we multiply to the terms is called the common ratio, and it is denoted by the variable r. So if you can see a variable r, it always signifies the common ratio. Okay, now how are we going to find the common ratio? Okay, the common ratio r can be determined by dividing any term in the sequence by the term that precedes it. Okay, for example, any term man daw. It says any term. So we can choose any term except for the first term. Okay, so we can choose any term from the second to the last term. So if we are going to choose 16, we are going to divide 16 to what term?
8.
Ako na to siya i-divide. Ni 32 or ni 60, ni 8?
8.
Ni 8. So 16 divided by 8, which is equivalent to pila man? 2.
2, sir.
Okay, so it means that the 2 that we just get is our common ratio. And these 2, if we are going to identify the next value or term after 32, we just multiply 32 with our common ratio. So what is our next term? It will be?
64.
It will be 64. Very good. If we will move to the next term, what will be its next value?
128.
128.
It will be 128. Very good. That is how we are going to identify the next term by identifying first the common ratio of the geometric sequence. Okay? Follow? Let's move. Let's now go to an illustrative example. Okay? This time, we need to consider geometric sequence 2, 6, 8, 54, and 162. And we are going to find the common ratio of this sequence. Now, how are we going to solve for R? Now, again, it says that we need to divide any term in the sequence by the term that precedes it. So it means we will choose. It's up to you which one you are going to start dividing those numbers. Okay? Example, we will start again with 18. We divide it with its preceding number, which is the before number, and that is 6. So 18 divided by 6, which is equivalent to
3.
Now, if we are going to check kung sakto magkatanan, if all of the answers are 3, we need to divide also the other numbers. For example, 162, we will divide it with 54. For sure, if you are going to use your calculator there, if you will manually divide the number, you will always get the value 3. So it means, what man? Our ratio, a common ratio is 3. Easy na? Because we are just looking for the common ratio. So by dividing the numbers or the values in the terms with its preceding number, we can always find the common ratio. Okay, another example. Given the geometric sequence 324, 54, 9, 3 halves, 1/4, and so on. What do you notice in the sequence?
Nagkaanam og kagamay.
Nagkaanam o kagamay. It's decreasing. Okay, now, can we still find the common ratio even if the sequence is decreasing? Can we still
Yes.
Yes, we can still solve. Okay, now let's just solve for the R. Let's start with 3 halves. Okay, 3 halves divided by 9. Now, how are we going to divide now the fraction with a whole number? Can you still remember how to divide a fraction with a whole number? What are we going to do first?
Concept.
Manay imaginary 1 ang 9, sir.
Correct. We can use the imaginary 1 of the whole number so that we can get 9/1. The other way is to find their LCD, or the least common denominator. Now, since it's too long math, we will just use the simplest way, which is to get the invisible one, okay, or the imaginary one of the whole number, which is 9/1. What's next? Both are already a fraction. What's the next? Reciprocal. Which number are we going to reciprocate?
Reciprocal.
Second.
The second number, which is the 9/1. If we are going to get the reciprocal of 9/1, we need to change the sign, the division sign, into a
Multiplication sign.
multiplication. So this form will be 3 halves times 1/9. Now, how are we going to multiply a fraction?
Times ragritso.
times dito.
You should
Sa every time,
a
we will
cancellation
multiply
pwede rin.
numerator to
numerator.
denominator
Yes.
to its denominator. So our answer will be 3/18. Now, can we simplify 3/18?
Yes, by dividing it
Yes.
3.
By dividing it by
3.
3. So we'll divide it by 3. So pila man ang ato answer?
1/6.
1/6.
6.
1/6. Oh, very good. Oh, that's 1/6. So our ratio, or our common ratio of this sequence is 1/6. Hello? Who can give me now the next term of 1/4? What's the next term?
1/24.
That's 1/24. That's very good. Okay, so you just multiply 1/4 with your common ratio, which is 1/6. So 1 times 1 is 1, 4 times 6 is 24. So your answer or your next term is 1/24. Okay? Now, next example. The first 4 terms of a geometric sequence are 1, -4w, -16w squared, -64w cubed. Again, common ratio, divide any terms to its preceding term. So we will just choose 16w squared divided by -4w. Okay? Now, how are we going to solve this type of equation na ay exponent involved? Are we going to change the division sign to multiplication sign? Or we're just going to directly divide them? Who can give me the answer? In dividing this type of numbers, what are we going to do? We always start with what?
Square root.
With the square root. Let's start first with its numerical coefficient, the 16 and the -4. Now, what will happen? We will divide them directly. So, 16 divided by -4. Ilang may answer?
-4.
4.
Negative
4. Okay? Now, this time, let's have the variables. How are we going to divide w squared and with w? What is the rule that you have learned in your previous grade level, grade 9, ang pag-divide sa exponent? What's the rule when we divide an exponent?
I-add ang mga exponent.
Minus.
You will
Subtract.
minus. So since w squared, dako man ni w, so w has what exponent does it have? It has an imaginary 1.
1.
Si w squared, minus na to with the 1 there. Okay? So, your 2 will be subtracted with 1. So, your answer will be 1. So, our variable here that will remain will be -4
4
w.
W.
Our And the answer will be negative 4W. Okay? Follow? Our geometric sequence have a common ratio of negative
4.
4W. Okay? Any question? Because we will proceed to the last example. Okay, for the last example, given the sequence, oh wait, given the sequence 4, 12, 36, give the next two terms. What's the next two terms? How are we going to solve first? We are looking for the next two terms. What are we going to do?
Find the common ratio first.
Let's find first the common ratio. Okay, so let's solve for the R. And we can choose either 12 or 36 to divide. So let's start with 36. We divide it by 12. And our common ratio is 3. Now, since our common ratio is 3 already, we can now solve the next two terms. And we can do this by multiplying R to the last term in the sequence to get the next two terms. So since in our sequence, 36 is our last number, okay, we will multiply 36 with 3. And our answer is 108. Okay? Since we are looking for the next two terms, and this is the first term, we can multiply again times 3 with 108. So the answer will be 324. Thus, the next two terms in the sequence are 108 and 324. Get it? Any question about common ratio? None? None so far. Oh, very good. Now, I want you later on after our session, you do your activity 1. Make sure that all your activities in that module will be answered. So in your activity 1, you're just going to solve for the common R or the common ratio, and you are going to identify the next 3 terms. So very easy, ano? So if you can find the common ratio, just multiply the last term, okay, with your common ratio to get the next 3 terms. Okay? So module 1 is, our lesson 1 is quite easy. Okay? So to summarize our lesson 1, geometric sequence, which is also called geometric progression, where each term after the first is generated by multiplying the preceding terms by a constant non-zero number. Always yun ha, non-zero number. Any number except for 0. Okay? Okay, what will happen if we will multiply it with 0?
0 royal po ng answer.
0 ang answer. 0 gapon
Which
ang
is
answer.
0. There will never be a geometric sequence that will happen in your answer. Okay, that is why we have to make sure that the constant is a non-zero number. Okay? And the common ratio R of a geometric sequence is solved by dividing any term by the term before it. Okay? So multiplying R to a term gives the next term. So again, mangita ganito sa common R, we divide. When we are going to look for the next term, we will just multiply the R that we just solved. Okay, remember that one, ha? Now, we are done with our lesson 1. Now, let's move right away to lesson 2, which is the general rule. Okay? Now, just the same with our arithmetic sequence, general rule is an important tool or a term that we are going, or formula that we can use in finding the next terms in your sequence. Okay? Now, at the end of this lesson, you are going to illustrate geometric sequences using the general rule. Okay? Now, before we are going to proceed with the lesson 2, activity na po ta. The one that we just learned a while ago. Okay, the common ratio. This time, we are going to identify or state whether each of the following sequence is geometric or not. Identify lang nato kung ang sequence nga gihatag sa given number is a geometric sequence or dili. Hello? We just look at the sequences and kindly identify which one are the geometric sequences. How about Annalyn Dinoy? Are you there?
Yes, sir.
Can you identify or state number 1? Is it a geometric or not?
Yes, it is.
It is. Can you identify what is the common ratio?
Four.
4. Very good. How about Jessamay Gopit? Number 2. Is it geometric or not? Is Jessa there? Si Karil Tuason. Is Karil around?
Sama sir.
Number 2. Is it a geometric or not?
Dili, sir.
Dili. Why?
Dili. Kay kanang pag-divide nako sa kanang 3 square root of 2 ug sa 5 square root of 2 kay ang gawas nga ratio kay 1.2. Nya gi-times nako suway ang 3 to the square root of 2 sa kanang sa 1.2 nga ratio niya, pero ang nigawas kay 6 to the square root of 2. Nya ang butang dira kay square root of 2 ra, so dili.
So that is not a geometric sequence. Okay, very good. Next, can I have Tricia for number 3? Geometric. And what is the common difference?
Geometric, sir. Geometric.
2. Very good. Positive,
2,
negative?
sir. 2, sir.
Negative. Oh, very good. Okay, that's
Negative,
not positive,
sir.
ha? Okay, on the next term, the 20 is already positive. Okay, negative 10 times
Yes, sir.
negative 2, the answer will always be positive. Very good. Next, can we have Isha? How about heavenly grace? Number 4. Is it a geometric or not? Hanilin. Ako ni si Hanilin, naadyo ni. Is it geometric or not?
Sir.
Yes, sir.
Yes,
It's
sir.
geometric.
Geometric.
Oh, number 5. Oh, Kathleen. Oh, Kenneth. Is Kenneth around? Wala, po si Kenneth. How about Kyla? Vicendario. Number
Not, sir.
5.
Dili.
Not.
Geometric.
Oh, that's not a geometric sequence. If you're going to look at the denominator, that's 369 and then 15. Okay? How about number 6?
Geometric, sir.
Isa
Ang common ratio kay 6 ay 0, sir.
Kisa to ni sabag. Kisha,
Gesha.
Go, Gesha.
Trisha, Kisha. Geometric nga.
Oh, geometric, sir. Kay ang common ratio sir kay 0.
Ay, that's not a geometric, my dear.
Kasi na, sir.
What is our definition a while ago? That each term after the first is obtained by multiplying the preceding term by a non-zero
Zero.
constant. Non-zero, dili is zero. So that is not a geometric sequence. Ha? Iwa man tayo ma-form diya nga sequence. Na din ay sequence. Nga puro zero ang naas number. Did you follow? If you are going to look at the definition, non-zero constant, okay? Which is not supposed to be a zero. So 6 will never be a geometric nor an arithmetic sequence. Follow?
Yes, sir.
Yes, sir. Tubag is gisya da. Tubag ra siya zero. Okay, so again, the common ratio of a geometric sequence is solved by dividing any term by the term before it. Okay, and multiplying r to a term gives the next term. Okay, always put that one in your mind. Okay, saan na to pag-solve sa common ratio and how to get the next term. Now, for the sequence that we had before, 2, 6, 8, 54, and 62, let us put this one in a table. Okay? Now, look at the two ways of writing the terms. What does 2 represent? What does the 2 there represent? Kani nga to? Kani? Wait.
First.
Kani nga to?
First.
What is
First
this?
term.
They are
The first term.
first term. Oh, that's correct. Okay? 2 represents our first term. Okay? For any 2 consecutive terms, what does 3 represent? Kani ang 3.
Common ratio.
Okay?
Common ratio nila.
It is the common ratio. Okay? If the position of the term is n, later na lang ta. What is the next term here? For A4 or the fourth term in the factored form.
2 times
2
3 times 3 times 3 times 3.
So how many 3's are there?
3.
There should be 3 already. Okay? So as we move to the next term, our common ratio also increases by 1. But in exponential form, how are we going to write it?
2 times 3
2
cubed.
times 3
2
raised
times
to the
3
power
cubed.
of 3.
2 times 3 to the power of 3. Now, question. What is the relationship between the 3 and the position of the term? Kung sa maiyahang relation na ni, kaning 3 ha, nga exponent, and its position, which is a sub 4 or the fourth term. What can you say about its relationship? Nabas la relation?
Y label.
Label? Nanay, label, oy. What do you observe with the exponent in the exponential form and its position?
Sir, -1.
-1. It means the exponent that you get in your exponential form is less than the number in its position. Okay? So as you move to the next term, its exponent will be less than its position. Hello?
Yes,
Now,
sir.
for the fifth
Yes,
term,
sir.
there will be 4 3's already. But if we are going to write it in exponential form, there will be 2 times
2 times 3 to the power of
2
4.
times 3 to the
Less
power
than
of 4.
its position, that is fifth term. Hello? Now, what if
Yes, sir.
it is already the nth term. Wata kay bound, so na siya nga position. It's the nth term. How are we going to write now the factored form? It should be look like this. Okay? You have times n at the end. And then in your, asa na to? 2 times 3 to the power of n minus 1. Why n minus 1?
Wa man ta ka ba kung ikapila na siya nga term.
Oh, remember also nga we are looking at the exponent which is less than 1 to our position. That is why the number is n minus 1. Hello? For example, we are looking for the 15th term. Ang itatas 15th term. So ang ato ang exponent there should be 15 minus 1 or exponent
14.
of 14. Hello? Okay. Now, by looking at it, your position 1 here in your term and your exponent here, which is 0, you have a relationship of n minus 1. And if you are going to identify the general rule of your geometric sequence, what will be the rule? Can you identify the rule? It should be a sub n is equal to the first term, which is a sub 1 times the common ratio to the power of n minus 1. Hello? Wherein a sub n is your nth term, or also called the general term. Okay? A sub 1 here is your first term, and your r is your common ratio, and n here is your position of the term. Okay? So, si a sub n, whatever is your value here in your a sub n, same value that will reflect in your n minus 1. Get it? Now, let's do the example. Consider the sequence 160, 80, 40. Give the general term of the sequence. Now, what are we going to do first?
Find the common ratio.
We will first find the common ratio. That's the first thing that we're going to need, the common ratio. Why? Because in our general rule, we need to identify first the a sub 1, which is our first term, and our r. Do we have the a sub 1? Can
Yes.
we identify the value of a sub 1? Yes.
160.
Identify the value of r.
Wala pa.
Diba? So a sub 1 is 160, and r is the one that we are going to solve first. So that's why we are going to solve for the common ratio. And how are we going to solve the common ratio?
Divide 80 by 160.
Divide 80 by 160. So 80 divided by 160, that is equivalent to 1/2. If we are going to change the form of 80 divided by 160 into a rational form, it will look like as 80 over 160. And the answer still is 1/2. Okay? Now, since we already have our common ratio, which is 1/2, this is the time that we can solve now our general term. So we are just going to substitute the values that we have already been given. We already have the a sub 1 and the common ratio. So we will get a sub n is equal to 160 times 1/2 to the power of n minus 1. It means that we are going to use this formula in order for us to find the terms that we need to look. Example, we are going to look for the 10th term of the geometric sequence. Since we already know the general term of this sequence, which is a sub n is equal to 160 times 1/2 to the power of n minus 1, we will substitute now the n. What is our n now?
10.
It's 10. 10. We will just substitute n with 10. So it will be a sub 10 is equal to 160 times 1/2 to the power of 10 minus 1. So 10 minus 1, that will be 9.
9.
What are we going to solve first?
1/2 to the power of
1/2 to the power of 9. Pila may answer?
1 over 5.
1 over 5, 1, 2. Is it correct?
Yes.
Yes. Is it not 1 over 18? Which one is correct? 1 over 5, 1, 2 or 1 over 18?
1 over 5, 1, 2.
Nga naman. Why what 1 over 512?
Ako man gi-calculate, sis.
I-calculate di ay. Unsa may
Ang
concept?
angkay tibuok nga kuan man gyud mo kailangan i-kuan sa power dili ra kay denominator.
Mo ba? Another explanation? It means 1/2 will be multiplied by itself 9 times. Like this. So 1/2 times 1/2, 9 times. Okay? You might have a wrong concept of the exponent when you multiply it. Dili kay 2 times 9 ha. It should be multiplied by itself 9 times. That's why your answer should be 1 over 512. What is next? What are we going to multiply? 160 times 1 over 512. Your answer should be 160 over 512. Is that our final answer?
No.
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 No. Really? No? O magangutana. No. Nganong no man? Can we simplify it?
Yes.
Yes. And what is the simplified form, Karil?
5. Ano sa to eh?
5 over 17. Okay, so this one is our final answer. And that is our 10th term of the sequence. That's 5 over 17. Hello? Next, example number 2. Consider the sequence 3z cubed, 3z to the power of 7, 3z to the power of 11. What is the general term? Again, first step, we are going to solve for the r. Okay? And we can choose either the first or the second term or the third term to divide with its preceding term. So let's choose 3z7 divided by 3z cubed. What will be the answer? So we will divide both numbers the numerical coefficient, 3 and 3. So the answer will be 1. And Z7 and Z3, what are we going to do again? If it is division, we subtract. So 7 minus 3. So your answer will be Z to the power of 4. And that is your common ratio. Okay? Now, let's now look for the general term. A sub n is equal to a sub 1 times r to the power of n minus 1. Okay? Now, let's supply now the given variables, the a sub 1 and the r. What is our a sub 1?
3z to the power of 3.
3z to the power of 3. And our r will be
Z to the power 4.
4. Sa yun ra kayo, more na siya. Okay, we are not going to solve anything. Kaya nga naman, we did not yet identify the n minus 1. Okay, so that is our final answer for our general rule or general term. So 3z to the power of 3 times z to the power of 4 to the power of n minus 1. Okay? Now find the next 3 terms. How are we going to find? Since we already identified the common ratio, we are going to multiply the r to the last term, which is 3z11. So 3z11 times z4. Now, saan ta na pag-multiply? Na ba yung numerical coefficient si z to the power of 4?
Naa.
Pila man?
1. Visible 1.
So 3 times 1, that is
3.
3. Okay? How about z11? What are we going to do?
I-plus ang exponents.
Oh, sa division, we subtract, di ba? Remember that the opposite of division is multiplication. Now, since we subtract that exponent in division, the opposite of it also will be division. So we are going to add 11 with 4. That is why your final answer for that will be 3z to the power of 15. Okay? Next, we will again multiply with z to the power of 4. What will be your answer?
3z to the power of 19.
Very good. That's correct. 3z to the power of 19. Since we are looking for the next 3 terms, we still need to multiply again the common ratio. And the answer is?
3z to the power of 23.
Very good. So, yun na kaya, no? Makatubag na good sila tanan. Okay? So, it's quite easy now. And you understand how exponent can be worked out if it is division or multiplication. Okay? So, the next 3 terms are 3z15, 3z19, and 3z23. Okay? This one, I think this will be the last example. Consider the sequence, the square root of 2, 2 times the square root of 6, and 12 times the square root of 2. How are we going to work with square roots? Let's first do the r. How are we going to do? Let's solve first 12 square root of 2 divided by 2 the square root of 6. What are we going to do first? Let's rationalize. When rationalize, we will take in rational form. It means we will change it to 12 square root of 2 over 2 square root of 6. So what are we going to do? Unsaon nato na?
Divide.
Divide? Yes, we divide it. But how can we divide it? We need to multiply both sides. Kani, both sides. The 12 square root of 2 and 2 square root of 6 by its denominator. So it means we will multiply. So nganong 2 over 6? 2 square root of 6? Because it is our denominator. Okay? Now what is the next one? What are we going to do? Pag-unsa man ta? We will group. We will multiply now. 12 square root of 2 to the 2 square root of 6. And then in the denominator, 2 square root of 6 times 2 square root of 6. So we will group them para di mo maglibog. So si 12 ug si 2 ato na i-combine. Yeah, si square root of 2 and square root of 6 ato po na siya i-combine. Okay? And then sa ubos sa mukha ni 2 times 2, then we have 6. Now, you might notice, nganong na 6 naman lang na siya. Nganong nawala man ang square root. What happened to the square root? Anybody can explain? Nobody? Okay.
6 times 6 man.
6 times 6, square root of 6 times square root of 6 is equal
Square root
to
of 36.
square root of 36. Now remember, in square root, we need to find the perfect squares. Okay?
Yes.
36 a perfect square.
Yes.
Yes. And what is the square root of 36?
6.
6.
It is
6.
That is why we solve it already. Instead of writing square root of 36, we just need to solve it right away. So we will just get right away the 6 for the answer of square root of 36. Hello? So our answer will be 24 square root of 12. So si 12 times 2 na imong 24. Si square root of 2, gi-multiply ni square root of 6, square root of 12. Then 2 times 2 times 6, we have 24. Hello? What's next? Siguhaton. We will, chaman, simplify this
I-factor
one. We
ang
will break
12.
up the square root of 12. Okay? We will look for the factors of 12. Which one of the factor must be a perfect square? Na ba?
4 times 3.
Times
Okay.
4
4,
times
sir.
3.
4
4
times
times 3, sir.
3. Okay, it's 4 times 3. Okay, which one is the perfect square there in the factors of 12? 4.
4, sir.
4.
It's 4. Okay, that is why it's 4 times 3. So si 4 here, mahimo na siyang 2. 2 times square root of 3. So your final answer is what man? 2 square root of 3. Any question? Anong na 2 square root of 3 man? Remember, si 24, i-divide nato ni 24. Nahimo na siyang 1. Okay? So imaginary 1 na siya. Ang nahibili na nato is square root of 12. I-break nato sila into a factor, which one is square root of 4 and square root of 3. Now, since square root of 4 is a perfect square and the answer is 2, ang nahabili nga square root is ang 3. So, idungan na nimo silang duha. Your final answer is 2 square root of 3. Follow? Any question? Pangutana. No more question? Wa galibog? O none. Since everything is clear, Let's consider the sequence now, looking for the general term. Since our general term again is a sub n is equal to a sub 1 times r to the power of n minus 1, and we already have our first term and our common ratio, which is 2 times the square root of 3, we can now substitute them with our general rule, which will be square root of 2 times 2 the square root of 3 n minus 1. Okay? Hello? Any question? Ota na, before we will end. So after this session, there are 2 activities that you need to answer. Activity 1 and activity 2. Questions? None? Okay.
Yes, sir. Kaning, sa example 1 ba?
Ah,
Kaning, di ba, sir, ang R kay equals ay 1/2 man. Pwede ra na 0.5, sir.
O, pwede na po
Isuwat
na
nimo.
0.5. Labi naggamit mo calculator. I know you are using
Oo,
calculator.
sir, kay malaw kog answer ani. Nya, 0.5 na akong gigamit.
Sige lang, it's acceptable. 0.5 and 1/2 are just the same. Decimal form lang na
Thank
0.5. Ah,
Oh, sir.
as much as possible, you have to learn how to solve with your hand. Manually, not your calculator. Okay?
Oh, sir.
Tayo, yan ang mong gamit. Pero kung gamay lang gani ang number, it's much better if you will use your manual solution. Okay, makapractice maguna siya sa inyong brain. Dili brain sa calculator. So, any more question?
Sir,
Yes, Mia.
na-record ni sir ay kanang in case makalimot mi sir ba, pwede ra mi mo tanaw sa imong channel, sir.
Pusyo, may lang gani kay nag-record ko ron.
Yes.
No?
Thank you, sir.
Sige. Okay, what else? No more question? None. So, remember this. For the general rule in finding the next terms of a geometric sequence, a sub n is equal to a sub 1 times the r, which is your common ratio, to the n minus 1, where your a sub n is your n term, which we call also the general term. Your a sub 1 is your first term. Your r, as again, said common ratio. And the n is your position of the term. Okay? So again, thank you for coming to our session. And again, I'd like you to subscribe to my YouTube channel. My YouTube channel is Trace, Trace. If you haven't subscribed yet, kindly subscribe. And thank you once again. Okay?